Okay, good morning, everybody. Thank you very much for following today in these activities that we have in the academic research group of cognitive processing and development. Today is a great honor for us to begin this new stage of the group by the support of the Vicerrectoría o de Investigación y Estudios de Posgrado de la Benemérita Universidad Autónoma de Puebla. And I thank you very much to the Vicerrector, Dr. Ignacio Martinez Laguna, and his team of technology and pedagogical innovation with Rogelio and Yadira. Thank you very much for this support. And we received today with a great honor Elisa Bake, PhD, the Dr. Elisa Bake from the Department of Psychology of the UCLA. And let me introduce our guest today in this talk with a little brief review of her career. So Elisa C. Bake, PhD, is currently a postdoctoral fellow at the Department of Psychology at the University of California, Los Angeles. She received her PhD from the University of Pennsylvania. Elisa uses neuroimage and network analysis to study various phases of social connection, such as what helps people to feel connected to others, what distinguishes people who are great at connecting with others, and factors that contribute to social disconnection. Her fellowship is currently supported by the National Science Foundation, SBE, Postdoctoral Research Fellowship. Her work has been published in various peer-reviewed journals, including the Proceedings of National Academy of Science, Psychological Science, and the Social Cognitive and Affective Neuroscience, and has been acknowledged with top awards at various academic conferences, including the Social and Affective Neuroscience Society and the International Communication Association. For us, it's a great honor to receive Dr. Elisa today here. And only as a quick comment, you can do all your questions there in the transmission. You are going to find a link. Please don't use the chat directly. Use this form to ask all your questions that are going to be answered at the end of the presentation. Elisa, thank you very much for this opportunity of being here with us. The stage is all yours. Welcome to the seminar.
Thank you so much. Thank you so much to the organizers for that introduction and for the invite to speak. It is truly an honor and privilege to be able to speak here today and to share some of my work with you. I look forward to engaging and learning from all of you, and I'm excited to talk about science. So let's get started. Humans are incredibly social, and feeling a sense of social belonging has been suggested to be a fundamental human need. Frequent pleasant interactions with other people through temporarily stable and lasting relationships are critical to meeting this need. Indeed, decades of empirical evidence has shown that when this fundamental need to belong is not met, it can have devastating effects on the individual. For instance, both objective measures of social isolation and subjective feelings of isolation have been linked to physical and mental impairment and illness, as well as an increased risk of mortality. Given that healthy psychosocial functioning has such a critical impact on our mental and physical well being, a lot of our energy is spent in connecting socially and to avoid social disconnection. Accordingly, we are quick to form social bonds, hesitant to break bonds once they are formed, and seek out positive social interactions when we experience negative ones, such as exclusion and ostracism. We also daily engage in many activities to foster and maintain social connection with others. For instance, we might spend time together with a friend sharing a pint of beer, send family members a postcard to let them know that we're thinking of them, or share a news article that we think a friend might find interesting. This ability to navigate our complex social worlds in order to meet our needs to socially connect is supported by our brains that dedicate a large amount of energy to help us coordinate socially. For instance, our brain has mechanisms in place that helps us in our abilities to understand each other's mental states, motivations, and behaviors, and to alert us when there are threats that can lead to social disconnection. These are brain regions that have been identified using neurosynth to be associated with mentalizing, or the regions of the brain that reliably activate when people are considering the mental states of others and engaging in social cognition more generally. Further, recent work has also started to look at beyond the individual brain in isolation and incorporate features of the complex social world that our brains are embedded in. These findings have observed that synchronization or coordinated brain activity between two individuals can have important behavioral implications that affect how well we connect with and understand one another. For instance, greater synchrony between people in certain regions of the brain has been shown to be associated with friendship, shared understanding and interpretation of events, as well as effective communication. So, in this talk today, I'll be presenting some of my work that highlights how shared processing of the world, as shown by convergent neural responses across brains, helps us feel close to one another. First, I'll start by presenting neural and behavioral evidence that underscores the role of information sharing as a fundamentally social act, one that we engage in to feel connected with others. Then I'll present some recent work that integrates social network analysis with neuroimaging and behavioral data that highlights neural responses that distinguish individuals who are really great at achieving this social connection. Or, in other words, individuals who are well connected in a social network or very popular compared to individuals who are less well connected. I'll then conclude by showing you some recent findings investigating subjective disconnection or neural responses that characterize individuals who experience high levels of subjective disconnection or loneliness. Together, these studies highlight how a shared sense of the understanding of the world around us, as reflected in convergent neural processing across brains, helps us feel close to one another. Great, so I'll start by presenting you evidence from a series of studies that highlights the role of information sharing as a fundamentally social act. As I mentioned earlier, we engage in a variety of activities daily and often without it feeling very effortful in order to support our goals to maintain social connection with one another. In this first part of the talk, I'll speak about just one of these activities that we engage in to connect with others that can have widespread consequences, sharing information. Information sharing is a ubiquitous human behavior and one that is certainly highlighted in the current media environment where people share billions of messages per day. And as we've seen in current events, this sharing behavior can have tremendous effects at the population level, influencing people's opinions, behaviors, and attitudes, highlighting the importance of studying and understanding the drivers of sharing behavior. But sharing can also have significant interpersonal effects for the individual who is sharing the message. For instance, sharing information can lead to interpersonal bonding with others through eliciting conversations about mutual interests. On the other hand, sharing a piece of highly controversial content might lead to disagreements and heated debates on your social media that has the potential to lead to conflict and social disconnection. So, in some of my earlier work that was done at Penn, we were interested in asking what drives us to share information with others. For the interest of time, I'll very quickly go over some of these results, but I'm happy to chat more about them in the Q&A. So in this work, we had a series of experiments where we had participants read news articles from the New York Times Health section and measure their brain activity inside the MRI scanner while they made various decisions. Here, I'll focus on brain activity in the mentalizing system that we defined based on a large study to be associated with or activated when people are thinking about other people's thoughts. First, we found that there was greater activity in regions of the brain involved in mentalizing while participants were thinking about sharing these news articles compared to when they were making other sorts of decisions that served as our control conditions. Further, this activity in the mentalizing system scaled with the extent to which participants wanted to share the article. So, the more that a piece of content evoked activity in these mentalizing regions of the brain, the higher the chance that participants were actually going to share it. In addition, we also found that activity in the mentalizing system contributed to an overall value signal in the brain that represents the subjective value of sharing a piece of information, which was then associated with how much the information was actually shared in the real world through social media and email. So, to quickly summarize this past work, we found that people consider social implications when thinking about sharing information, and the extent to which a piece of content engages the system in the brain is associated with both individual and population level sharing behavior. These results seem to suggest that social considerations drive sharing behavior, such that people are more likely to share information when it elicits greater social thoughts. While this early work has contributed greatly to our understanding of sharing behavior, it is limited in that it has only looked at the sharing of short text, looked at time average brain activity in regions, and observed brain activity while participants were explicitly instructed to think about sharing. But this doesn't capture much of how we often encounter content that we end up sharing in everyday life, where that content unfolds dynamically over time, as does our mental processing, and where we might be thinking or attending to any number of things while encountering content before deciding to potentially share it. Therefore, in a recent study, we built upon these prior findings to ask what types of spontaneous brain activity predicts the sharing of dynamic naturalistic stimuli that unfolds over time. In our study, participants watched 14 different naturalistic stimuli or videos while they were in the MRI scanner. Participants were not given any explicit instructions to process the stimuli in any way, but to watch naturally as if they were watching at home. This allowed us to capture neural activity as it ebbs and flows to dynamic naturalistic stimuli. After the scan was completed, participants then rated their likelihood to share each video. To analyze the brain data, we used a method called interceptor correlation. As participants were watching these videos, we extracted the time series in each brain region across the whole brain. Here, I'm just showing you a toy example of just two regions and activity unfolding in these regions as the subjects are watching this video. Then, for each unique pair of participants, we can correlate the corresponding time series in each brain region, which gives us a measure of how similar responses in each brain region were for each pair of participants. We calculated this measure of neural similarity for each unique dyad in each region of the brain for each video. We then tested whether there was greater neural similarity in certain regions of the brain when people are more willing to share a video compared to when people are less willing to share a video. This approach allowed us to test whether videos that bring people's brains into sync, as reflected in greater neurosimilarity, would also be more likely to be shared. And here's what we found. We found that intersubject neurosimilarity was associated with increased sharing likelihood in several brain regions. These included both regions involved in audiovisual perception as well as regions involved in social processing, like understanding others' mental states, such as the precuneus, the temporal parietal junction, and the superior temporal sulcus. Regions that were also identified in my earlier work where greater magnitude of activity was associated with sharing of text based content. This new set of findings extend this past work to suggest that content that synchronizes activity across brains is more likely to be shared, or that content that elicits similar interpretations across a group of people will be more likely to be shared. This raises the question, do people want to share content that they think will be similarly interpreted in their social circles? Or is this association possibly due to other factors? For instance, that content that is more vivid or exciting in trained brain activity and are also more likely to be shared, even if participants have no idea what their peers might think of it. So, based on our fMRI results, we conducted a follow up behavioral study to ask, are people more willing to share when they believe others would have similar views about the content as themselves? We conducted this pre registered online survey where participants saw 5 different news articles and rated their perceived congruence on the extent to which they believe that others in their social circles would share their views about the content of each article. They also rated how likely they were to share each article. And here's what we found. We found a robust association between perceived congruence and sharing likelihood, such that people are more willing to share content when they believe that others in their social circles would hold similar views about the content as themselves. And this association was significant even after controlling for the extent to which people found the content to be interesting and how positive or negative they found the content to be. So, given these promising correlational results, where we found that the perception that others in your community would have similar views about the content is associated with your likelihood of sharing that content, we next conducted an experimental study to test whether we could causally increase the likelihood of sharing by experimentally manipulating perceived congruence. In other words, here we were interested in whether perceptions of convergent interpretations cause people to want to share content. We did this through experimental manipulation. To do so, we recruited undergraduate students from UCLA online. So if you are a participant in this study, you will first read news articles like this, and then provide a bunch of close-ended ratings and written opinions about the articles. Don't worry about reading the small font here. This is just an example of the different types of ratings that participants provided. We then told the participants that we had gathered data from other UCLA students in the prior academic quarter about the same articles that they had just rated, and that we would run a model to determine how similar their opinions about the articles were to other UCLA students' opinions based on all the closed and open ended responses that they provided. In actuality, though, this feedback was experimentally manipulated. So after explaining this, we ran a little calculating screen like this to encourage participants to believe that we were running this model to calculate how similar their responses were to others' opinions. And then they saw one of two types of feedback that were experimentally manipulated. We provided feedback in the form of multidimensional scaled or MDS plots. We explained the premise of the MDS plots and how to interpret them to our participants, and pilot data as well as manipulation check questions confirmed that participants understood the plots as intended. And here's what the plots look like. Participants always saw their own response on the plots as a star. For articles in the unclear condition, participants saw a plot like this, where the dots that represent other students' opinions are scattered randomly about, indicating that there's no real consensus on people's opinions about the article. For articles in the congruent condition, participants saw a plot like this, where the dots that represent other students' opinions are all clustered together, indicating that everyone had similar views about the article and that the participants' own opinions were also similar to the group's. After receiving this feedback, participants then rated their likelihood to share the article. And here are the results from this experimental study. These are regression coefficients from a mixed effects model predicting sharing from our experimental condition with all the message level characteristics as control variables. We saw that when participants received feedback that there was a congruence of opinions about the news article and that their own opinion was similar to their peers, they were more likely to share compared to when they were led to believe that there were mixed opinions about the articles in their community, while controlling for other message level characteristics of the articles that may be associated with sharing. So combined, our findings suggest that content that evokes more similar neural responses across people is more likely to be shared. And further, the perception that content will evoke similar responses across people is associated with the desire to share that content. And this perception appears to play a causal role in driving information sharing, as when we led people to believe that people in their community responded similarly to a piece of content, they became more likely to want to share that content. Overall, our findings corroborate theories of information sharing as an inherently social behavior that helps us maintain social ties and cultivate a sense of shared meaning, and that we share information to feel connected with others through sharing our viewpoints about the happenings of the world around us. So, I've just shown you some findings that suggest that information sharing is a fundamentally social act, and that the extent to which our brains synchronize with our peers' brains is important in whether or not we will share a piece of content, and that coordinated brain activity across people may capture communal values in a social group that helps us relate to one another. In this next part of the talk, I'll focus on how individuals who are really great at achieving social connection in a social network may be distinguished in the way that they process the world around them. As I previously mentioned, social connection has critical impact on the well-being of individuals. Being central in a social network with a large number of friends is one protective mechanism against social disconnection. In a real life social network, some people are more central than other people. So consider Ben here, who is centrally located in this toy network with 7 friends or a degree of 7, and compare him to Matt, who has just 2 friends or a degree of 2. What distinguishes Ben, who is highly central, from Matt, who is less central in this social network? Or in other words, what distinguishes popular individuals? One possibility is that popular individuals, who many indicate as a friend, may process the world around them in a way that makes it easy for them to forge connections with others in a way that many others can relate to them. So, for instance, here, if this is a similarity matrix where each row and column is a subject and each cell represents similarities in viewpoints between two subjects, it's possible that Ben, or subject 1 here, who has many friends, would have highly similar ways of processing the world around him as other people in his network, as seen by the varying shades of red between him and every other member in his social network here. And this greater mean similarity with others in the social network may be either a cause or a consequence of his central position in this social network. Correspondingly, it's possible that Matt, or subject 2 here, who has less number of friends, would have less similar ways of processing the world around him compared to others in his network, as seen by the varying shades of blue and neutral colors between him and every other member in his social network. And as a result, Matt may hold a less central position in the network, potentially because he processes the world around him in a way that isn't reflective of the group norms or is more idiosyncratic. So, in the current study, we tested this theory and asked, do popular people process the world in a more normative way compared to less popular people, which may help them connect with a greater number of people and hence be associated with greater centrality in the network? We recruited first year university students who were living in the same residence hall and had them fill out a social network survey online, and a subset of them also participated in a neuroimaging study. In the social network survey, participants are asked to nominate their friends, which we operationalize as in past research, as the people who they regularly spend their free time with. We then use this data to calculate for each individual how many times they were nominated by their peers as a friend or their in degree centrality. A subset of the participants also came in for a neuroimaging study. And as in prior work that I showed you earlier, participants' brain activity was measured as they watched 14 different videos that ranged in topic. And these videos were chosen to allow for variability in how people may interpret, react, and attend to them, so that different people may interpret the videos differently. We again used intersubject correlation to analyze this brain data, where similarity in time series in each brain region was obtained for each unique pair of participants as they watched these videos. Again, to ask this question, do popular people process the world in a more normative way? We took this approach. For each region of interest in the brain, we represented intersubject correlation in that region of the brain in the similarity matrix, where each cell represents the correlation of time courses in that brain region between two subjects. Then we calculated the mean of each row, which gives us how similar, on average, each subject's neural responses were compared to every other subject's neural responses. And again, we did this across the whole brain, so we get one number for each brain region for each subject that indicates how similar that subject's neural response in that brain region were to the rest of the groups. We can then integrate information about people's social network centrality to test, for instance, this hypothesis that people like Ben, who is very popular in the social network, who many indicate as a friend, has on average greater neurosimilarity with the rest of the group compared to people like Matt, who is less popular in the network with a fewer number of friends who indicate him as a friend. And here are the results of those analyses. The regions that are in shades of red here are regions where popular individuals showed greater mean similarity with the rest of the group compared to less popular individuals. And the regions that are outlined in black are significant after multiple comparison corrections. Notably, these regions include the bilateral dorsomedial prefrontal cortex and the precuneus, regions that are often implicated in social cognition as well as shared interpretation of events. These findings seem to suggest that popular people do process the world around them in a more normative way, in a way that is more similar to the rest of their community members, particularly in the ways that they may derive social meaning and significance. So, I've just shown you some evidence suggesting that popular people process the world in a way that is more similar, on average, to other community members. One possibility, though, is that people process the world around them similarly to people who have similar characteristics to them. So, in this case, one possibility is that popular people, such as Ben, may process the world similarly to other popular people, but dissimilarly to unpopular people. Correspondingly, unpopular people may process the world similarly to other unpopular people, but dissimilarly to popular people. Another possibility, though, which reflects a famous line from the novel Anna Karenina, which says that happy families are all alike, every unhappy family is unhappy in its own way, is that all popular people will be similar to one another and different from unpopular people, but that each unpopular person will be dissimilar from the group's normative way of processing the world in their own distinct idiosyncratic way. This way of looking at neurosimilarity was suggested as a framework recently to study individual differences by Emily Finn, who we've started to collaborate with on this work recently. Thus, we next tested this theory and asked, do popular people process the world similarly to each other, and do less popular people process the world in an idiosyncratic way? So, in order to answer this question, we took this approach. Given the time courses in each brain region for each subject, we then incorporated these neural time courses with each subject's real life social network centrality to test, for instance, if subjects 1 and 2, who are both popular in the network with a large number of friends, have greater neurosimilarity compared to subjects 65 and 66, who are less central or less popular in the social network with fewer friends in the community. Here, I want to pause a little bit and explain further how we did these analyses and what I mean by when I say that we tested the Anna Karenina principle. So, say that we have this matrix here, where, as in previous analyses that I've shown you, this represents the inner subject correlation in this specific brain region, and where each cell represents a correlation of time courses in the brain region between two subjects. We can then order the rows and columns by subjects in degree centrality, such that people with the lowest in degree centrality or the least number of friends would be on the top left of this matrix, and people with the highest in degree centrality or the highest number of friends would be on the bottom right of this matrix. Given this, we can then test the Anna Karenina principle by testing whether there is greater neurosimilarity in dyads who are both very popular compared to dyads who are both very unpopular. As an alternative hypothesis, we can also test whether neurosimilarity clusters based on similarities in popularity status by comparing whether dyads who are similar to one another in degree centrality would be more similar in neural responses compared to dyads who are not alike in their popularity. For example, we can test whether dyads who share popularity status, such as dyads where they're both unpopular, would be more similar in their neural responses compared to dyads where one person is very popular and the other person is unpopular. So, to make this just a little bit more concrete, going back to the two possibilities that I posed earlier, if it's the case that people are similar to others who share popularity status as them, such that unpopular people will be all similar to one another and popular people will be all similar to one another, we'd expect to see something like this, where in a given brain region, the dyads who are unpopular would show similar neural responses to one another, and dyads who are popular would show similar neural responses to one another, and dyads who are different in popularity status would show dissimilar brain responses. So you can see here that people cluster based on their popularity status, such that people who are unpopular with low in degree would show neural responses that are similar to one another, and the people who are very popular with high in degree would show neural responses that are similar to one another, as you can see by the shades of red here. And when there are dyads with mixed in degree centrality, such that one person is really popular but the other person is not, they would show dissimilar brain responses, as shown by the shades of blue here. This is the standard way of relating behavioral data to intersubject neural correlations, where we often test if more similar behavioral outcomes are associated with more similar neural responding. However, if our theory based on the Anna Karenina principle is supported, where every popular person will be all like, but that each unpopular person is dissimilar and idiosyncratic in their own way, we would expect to see something like this, such that we see greatest neurosimilarity in our highly popular dyads, as seen by the dark shades of red on the bottom right of the matrix, and the least neurosimilarity in the unpopular dyads, as shown by the dark blue shades in the top left of the matrix. This would mean that unpopular individuals process the world in a way that is very dissimilar to one another, whereas popular individuals all process the world in a way that is similar to one another. Okay, so to summarize, we tested whether popular people process the world similarly to each other, as shown by similar neural responses between popular individuals, whereas less popular people process the world in an idiosyncratic way, as shown by less similar neural responses between less popular individuals. I'll now show you the results from these analyses. All the results that I'm about to show you control for demographic variables that may lead to neurosimilarity, including friendship between the dyads. First, I'll show you the results that compare neurosimilarity in highly popular dyads versus neurosimilarity in unpopular dyads. So here I'm comparing whether people in this lower right corner of the matrix, where both individuals are very popular, would show greater neurosimilarity with one another compared to people in the upper left of this matrix, where both individuals are unpopular. Just wanting to set this up for you here, since this is a contrast analysis where we're comparing neurosimilarity in highly popular dyads to neurosimilarity in less popular dyads, any regions that are in shades of red would represent the Anna Karenina effect. That is, they are more similar in dyads with high in degree, who many indicate as a friend, and less similar in dyads with small in degree, who are not as well connected. Correspondingly, the regions that are in shades of blue would mean that they are more similar in dyads with low in degree or unpopular dyads, and less similar in dyads with high in degree who are popular. Okay, and so here are the results. Again, the regions that are outlined in black are statistically significant. One thing that you can see here is that most of the brain is in shades of red, meaning that there is overall greater neurosimilarity in popular individuals compared to less popular individuals. Notably, the regions that are more similar in these popular individuals include regions that we found were implicated in the subject level analysis that I showed you earlier, regions that have been previously associated with shared interpretation of events and social cognition, such as the medial prefrontal cortex, the precuneus, as well as parietal regions that determine what aspects of the world around us people pay attention to. So combined, our results seem to suggest that yes, popular people process the world in a way that is more similar to one another, whereas less popular people may process the world in a way that is more idiosyncratic. I also want to show you what the results of the other contrasts look like. So I just showed you these results where we compare neurosimilarity in dyads who are both very popular or both high in degree centrality with neurosimilarity in dyads who are both unpopular or both low in degree centrality. We can also compare neurosimilarity in highly popular dyads. So again, this lower right corner of the matrix with dyads that are mixed, where one member of the dyad is very popular and the other member of the dyad is unpopular. And here are the results of those analyses. So here we can see that dyads who are very popular are more similar to one another than dyads where one person is popular but the other person is unpopular. Finally, we can also compare neurosimilarity in mixed popularity dyads. So again, the gray areas of the matrix with dyads that are both unpopular to see if mixed popularity dyads would be more similar to one another than dyads where both members are unpopular. That is indeed what we found. Diets who are both unpopular were less similar to one another than to popular people. This really highlights that less popular people do process the world in an idiosyncratic way that is dissimilar to everyone else and one another, whereas popular people process the world in a way that is similar to one another. So, to quickly summarize this part of the talk, we were interested in asking what distinguishes popular individuals. And we found that popular individuals within a community process the world around them in a way that is more reflective of the group's normative way of processing the world, as indicated by greater mean neurosimilarity with the rest of the group. And we also found support for the Anna Karenina theory that popular individuals also process the world around them in a similar manner to one another, whereas each unpopular person is dissimilar and idiosyncratic in their own unique way. So far, I've shown you some findings that suggest that information sharing is a fundamentally social act and how coordinated activity across brains can help us identify content to share with others that may foster social bonding and connection. And I've also just shown you some findings that suggest that individual differences in the extent to which people show coordinated brain activity with others in their social circles is related to how popular they are in their social networks, and that popular individuals show brain activity that is more coordinated with one another, whereas less popular individuals are idiosyncratic in their own ways. But of course, our sense of social connection doesn't just depend on the number of people that we socialize with. Some people might feel totally socially fulfilled with just one or two good friends, and others might feel lonely even when socializing with lots of different people. So, in this last part of my talk, I want to shift gears a little bit and focus on what neuroresponses can tell us about people's subjective sense of social disconnection, or in other words, loneliness. As I mentioned in the beginning of my talk, feeling a sense of social connection is critical to fostering well being. There's a lot of evidence now that have linked both objective social isolation and subjective feelings of isolation or loneliness to physical and mental impairments and illness, and increased risk of mortality that persists even after controlling for comorbidities. Feeling understood is one critical factor in achieving social connection, and deficits in self reported feelings of being understood are a risk factor for loneliness. Yet it is currently unknown what factors contribute to these feelings of disconnection in lonely individuals. For instance, lonely people may tend to feel misunderstood because they exaggerate or misperceive how dissimilar others' views are to their own, or they may feel misunderstood because they actually see the world in idiosyncratic ways that is dissimilar to others in their community, which may contribute to feelings of disconnection due to a lack of shared understanding. Here, we use neuroimaging to test whether lonely people actually process the world around them in an idiosyncratic way. To do so, we again tested the Anna Karenina principle, which again reflects the famous line from the novel, "Happy families are all alike. Every unhappy family is unhappy in its own way." Similarly, here, we tested whether not lonely individuals would be similar to one another and different from lonely people, but that each lonely person will be dissimilar from the group's normative way of processing the world around them in their own idiosyncratic way, which may contribute to a sense of lack of understanding and feelings of isolation. So, to test this theory, we used the same data set as the results that I've previously shown you, where we recruited students who are living in the same residence hall and conducted a neuroimaging study where their brain activity was measured while they watched 14 different videos. The participants also completed a questionnaire where they self reported subjective loneliness. We again used intersubject correlation to analyze this brain data, where similarity in time series in each brain region was obtained for each unique pair of participants as they watched these videos. We then integrated this neural data with each subject's loneliness ratings to test the Anna Karenina principle, similar to how we analyze the data for the analysis investigating neural responses that distinguish popular individuals. We tested, for instance, if less lonely individuals, such as subjects 65 and 66 here, would be similar to one another, but dissimilar to lonely individuals. But individuals who are highly lonely, such as subjects 1 and 2, would be dissimilar to one another as well as the rest of the group. Or, in other words, we asked, do lonely people process the world around them in an idiosyncratic way that may contribute to feelings of disconnection that may lead to loneliness? In these analyses, we also controlled for the measures of objective social connection by controlling for the number of friends the participants reported having. And here's what we found. Again, all the results I'm about to show you control for demographic variables that may lead to neurosimilarity, as well as objective social connection, or the number of friends that participants have. Just to orient you here, unlike in the last study, we'd expect lower values of our behavioral variable, loneliness, to be associated with greater neurosimilarity. In other words, we'd expect a negative relationship between loneliness and neurosimilarity. So cooler colors here would indicate support for our hypotheses. And that is exactly what we see throughout the brain here. The regions that are outlined in black again are statistically significant. Notably, the regions that are less similar in lonely individuals include regions that have been previously associated with shared interpretation of events and social cognition, such as the medial prefrontal cortex, as well as regions that have been associated with friendship, including the inferior parietal lobules and the superior temporal sulcus. While not visualized here, we also saw that lonely individuals showed less similarity in brain regions associated with reward processing, including the nucleus accumbens and the pallidum. So, combined, our results seem to suggest that, yes, lonely people seem to process the world around them in an idiosyncratic way, in a way that is dissimilar to their peers, which may contribute to the reduced sense of shared understanding that often accompanies loneliness. And since these results hold, even after controlling for the number of friends that people have, our results suggest that being surrounded by people who see the world differently from oneself may be a risk factor for loneliness, even if one regularly socializes with them. Combined, our findings add insight to the processes that may characterize loneliness and suggest that interventions that help identify common grounds for shared understanding between individuals may help mitigate loneliness. So, in conclusion, I first showed you some findings that suggest that information sharing is a fundamentally social act and how coordinated activity across brains can help us identify content to share with others that may foster social bonding and connection. Then I presented findings that suggest that individual differences in the extent to which people show coordinated brain activity with others in their social circles is related to how popular they are in their social networks, and that popular individuals show brain activity that is more coordinated with one another, whereas less popular people are idiosyncratic in their own ways. Finally, I just showed you that individuals who are lonely process the world around them in an idiosyncratic way, perhaps contributing to a sense of lack of understanding that often accompanies loneliness. In conclusion, findings from all three sets of results suggest that a shared sense of the world around us, as reflected in convergent neural processing across brains, helps us feel close to one another. I want to conclude my talk by quickly highlighting some future directions that I'm particularly excited about in building upon some of the findings that I showed you today. So, in future work, I'm interested in testing the causal direction of some of the effects that I've shown you. For example, to see if we could predict who will become centrally located in a social network using their brain activity, and to test whether people's brain responses change as a result of the social network position that they end up occupying. I'm also interested in social rejection and specifically how individual differences in subjective and objective social connection might relate to individuals' neural and behavioral reactivity to ostracism or rejection, as well as to what extent such reactivity may be adaptive or maladaptive. I'm also interested in testing interventions that can increase neurosynchrony between individuals in a community and help foster social bonding, particularly in individuals who are at most risk for social disconnection. Overall, I think that this is a really exciting field to be in because so many questions remain in integrating aspects of our extremely complex social world with the way that we process the world around us, which we can gain insight into by observing neural responses to rich, dynamic, naturalistic stimuli that unfold over time, and how these social and neural features may be associated with how well we connect with and relate to one another. I want to conclude by thanking my collaborators on my past and present work, as well as my former and current lab members, and as well as funders, and all of you for your attention. I look forward to answering your questions during the Q&A.
Perfect. Thank you very much, Elisa, for this great talk. I really enjoy it. I think it's a very, very interesting topic. I think it's a crucial in this time of this with the pandemic and the information sharing that we are mostly doing it by online platforms and other media. So I invite all the people that are connected today with us to ask their questions in the form. And I have a couple of, well, not a couple of, I have a lot of questions that I put here in my notes that I would like to begin with in order to wait for some questions for the audience. But I have several questions from the different themes. So I want to start in order that I was writing it. So
Sure.
the first one is, well, we see here in Mexico, I don't know if in the US or in other places in the world happen the same thing, but we see often that in WhatsApp, for example, that the people start sharing some chains of information, some of them misleading or some of them as a fake news kind of information. So how can this be I don't know, beneficial or some utility for the people of sharing some information that it doesn't have the support or the scientific support for the evidence? How this dynamic can affect, for example, the closest circle or start losing some connection with the people?
Yeah, that's an excellent point. There's a lot of work now being done. I personally haven't been involved, but in targeting misinformation and also trying to identify interventions that can prevent people from spreading misinformation. And I do think that sharing misinformation, depending on your social circles, can be quite risky, right? I think that it can cause a lot of tension on social media, on their page as well. I think that speaking from my findings, that people are sharing this because they want to socially connect with others, and um, it does seem that unfortunately a lot of misinformation gets spread because they believe that others in their social circles would believe it as well, or get agitated together. So that's quite a challenge. I think my work shows that those motivations are social. It's like socially motivated in its inherent core. So I do wonder if we can intervene with misinformation with a socially framed intervention. That if you spread this information, it might cause harm in your social media, or maybe even in, if you share this, it might um, cause conflict for you because people are going to disagree. And I do wonder if those strategies that really tap into the motivations behind why we share information in the first place might be effective strategies to intervene in those processes.
Yes, and then and it's excellent because I think, and my question goes now in the other direction, that, for example, now with the COVID-19 virus, that there's a lot of information, really misleading information around. But for example, I'm going to put maybe a naive example here, but these kind of talks that we are having with you today, that are based on this research and evidence, that are not so popular, as for example some misleading information that spreads very quickly, how this can affect also the popularity and not popularity networks that maybe see the world in a same way, but it's not like a right way to see it. I don't know if I made myself understand.
Yeah, no, I think that is such a big challenge, because, and it's connected to my answer to the first question, is that we do this to socially connect, and then if you're in a network where everybody believes in the or would have similar views about the false content, then you're more willing to share it, right? Because you want to bond with those people. So yeah, I think it's very, very tricky, and I don't have a good answer to how we can mitigate that. I mean, I think to speak to some of your first elements of the talk about why scientifically based content doesn't go viral, I think that is something that as psychologists and as scientists, we need to work a little bit better on how to make it a little bit more translatable to the public as well. So some of the work I think falls on us. Yeah. I don't know if I answered your question in a satisfying way, but I also think that, communicating across the aisle so that our social circles are a little bit more diverse is important. But these are such big issues that I don't think we have an easy solution to.
Perfect, perfect. Another question that I have, and I invite all the people to ask their questions. Another that was I was thinking is, I remember that I listened one day, Adam Grant, this organizational psychologist, that he was talking about the idea of that if you get closer with people that think alike, like you don't get productive, or you don't get challenged by this thought. So I don't know if you have think or do some research about what happens if you can have a challenging thought, like somebody that is in your circle but is not representing the same idea or the same way of thinking as you have, in terms of this neural activity, in order for, I don't know, for get to challenging the thought and maybe more productive in the ideas. I don't know if you have think about that.
Yeah, yeah, that's an excellent point. Yeah, so my work, I think, is a little bit descriptive, right? We're kind of saying this is what's happening. This is how people are congregating. I think one, at the moment, we don't know the causal direction of the effects, which we were going to actually, we were trying to, the study was supposed to be longitudinal so that we see to what extent people become friends with people who already see the world in a similar way. versus how much as a matter of becoming friends, you end up becoming more like your friend. I mean, I think the answer is probably both to a certain degree. Like you become more similar to people that you surround yourself with, but you're also more likely to be friends with people that already see the world in a similar lens. So I think getting at that piece would be also really interesting, because if and to what degree we see that people become more similar with friends that they end up becoming, that gives us a little bit more hope. I think if you have a community where people have different perspectives and thoughts of seeing the world, and you can get them to start communicating with one another, I think that they might end up at a place that is somewhere in between, right? If you have two extreme views, let's say. I do know of some work that I personally haven't done, but some work that's being done at UCLA psychology, whereas in the United States, as I'm sure many of you are aware, unfortunately, we have this crazy partisan divide, right, with the left and the right, which I think is happening all over the world as well. So researchers have shown that just by getting people in the same room and communicating, and they come out with a less extreme view and more of seeing the other person across the aisle as a human as well, and like seeing their perspective. So just by communicating, which I would be just by initiating communicating or intervening in a way where people who have different views in a community can communicate with one another, I think it already increases neural synchrony, neurosimilarity, and will help us in this divide. And that is something that I'm very interested in pursuing, especially when we have a community that is relatively closed network, like the way that we do here with residence halls where everybody's living in the same dorm. You can already see who are in the outskirts of the community, and if you get people to like talk, I think that that might be a fruitful intervention and maybe good for everybody.
Perfect. Thank you very much. And I have a question that is more like a methodological kind of question, because maybe this could be very interesting for our students. As you mentioned, your research is based also in this fMRI, if I understand correctly.
That's right.
Here we have well, more complicated situation in getting with an fMRI, but how can be, or what can we do for in the behavioral side, or as a EEG study for looking for this kind of topics?
Yeah, I think with EEG, there's a lot that you can do with EEG, where you can. Well, EEG has the advantage in that you can have two, if you have two EEG systems, you can have two people who are actively communicating with one another and then have both of their brain activity measured. So I think that a total design that can be completely replicated with EEG here would be just to look at similarities. I mean, if you could do the whole entire study that we did here with the EEG context, and just showing them videos and then seeing how similar person A versus person B is. And then I think EEG is really exciting in that then you can get them to communicate, like some of the interventions that I was talking about, and see how can they sync up more in their brain activity when they're talking about topics, especially if people are coming from very different viewpoints, and kind of the interventions to help people connect better together. Yeah, I think EEG would be really exciting.
And for example, we to work a lot with doing some Bayesian approach for doing some inferences in these neural images or these neural data. So my question is a little bit, if you can talk us about a little bit about the analysis of your data. How do you perform? What kind of tools, in statistical tools, do you use for your studies?
Yeah, so I haven't done any Bayesian work with this study. So these are it's a little bit complicated because they're dyadic data, so they're not independent for statistical analysis. So to analyze this data, I use multi-level modeling to account for the dyadic structure, and also because for the video level analysis, like there's also the video level dependency structure. So then we get for each unique dyad in the study, like one measure of brain similarity between the dyad in each region of the brain. and then some behavioral measures that we're interested in, like similarity in their popularity, let's say, then you can predict that. But then we're using multi-level modeling to account for the nesting or the non-independence due to the repeating dyads and the videos as well. There's this one paper that explains it very well that I'm happy to forward if anyone's interested in analyzing this sort of data and then accounting for the nested structure using multi-level modeling.
No, really, really, I appreciate a lot if you can send us this information because
Yeah.
listen to your talk. As I told you in the email, we admire your work, we admire your career. But today's talk is amazing. Also, it's amazing the thing that you are talking today. And I have a final question here, Elisa, if you allow me. In the last part for the loneliness. I don't know if you have some numbers about the increasing or decreasing of loneliness in this pandemic. Also because I see it a lot in I don't know, in Facebook primarily, that you can see a lot of phrases or quotes that mention about loneliness and not feeling connected with the world, and also about I don't know, the teaching online and feeling lost about this. How can this affect or how can have an impact or making some intervention about this, that the loneliness doesn't go to develop some psychological consequences? I don't know, maybe depression or anxiety, primarily, for example, in our students, but also in the people in general.
Yeah, yeah. I think loneliness has definitely increased during the pandemic. I think there's a ton of studies now. And as you alluded to, I'm not doing this work personally, but I've been attending a conference this past week, and a lot of researchers are focused on kind of scraping like Twitter data or Facebook data and finding, I think, linguistically, there's a lot of language associated with loneliness and depression and sadness more generally. Yeah, I think it's definitely a challenge because as I mentioned over and over in our talk, social connection is so important to our not only our mental health but also physical health. And I think with the global pandemic going on, it's very hard to say what we can do because I do think that virtual interactions are not as satisfying, unfortunately. But what I'm also interested in doing, which may tap in or not to this question, but this finding that we have some finding that I didn't show you today, that just the sheer um, sharing of information with others or thinking about sharing information with others already makes you feel close to the person that you're going to send it to, which is really fascinating. So some of my collaborators have been thinking about, would that be even like a nice intervention? Because that's so easy to do, unless we have got to be a little bit careful of like people spreading fake news as well. But just sharing something with somebody else, which is very easy, I think, to do, might even help us feel connected. I think it would help just a little bit. But yeah, it's definitely challenging in the pandemic.
Yeah, and that's why, Elisa, we have this scenario, these talks, and in order to see that we are not alone. In fact, we are connected with these platforms. We can have this talk in real time with you in the US, and we can have this connection despite the fact that we are having this pandemic. So I think it's quite amazing and crucial, your work. So I really appreciate that you share it with us today because it's amazing. I don't have any more words to describe it. So thank you very much, Elisa, for that. And well, we don't have another question here, but if anybody has a question for the end. But just to close, Elisa, today, I always ask this question to my speakers, and I want to ask you also to you, Elisa. We are trying to build this group, especially for students, undergraduate students, female undergraduate students primarily. And I always ask for a final reflection about the research that we can do and the path that we can follow in the research in different areas, because I think what you today talked us about is really is related to our work in the group of Cognimat, because we are trying to study this kind of things. So I want to ask you for a final reflection of the difficulties about doing research in the pandemic with the COVID, but also to motivate us to follow a path in this area. That not to vanish in the deception of all the things that are happening in the world, but motivate and continue doing some work in research. Please, Elisa.
Yeah, yeah, there are definitely challenges, I think, with the pandemic, but I think as you said earlier, that there's such excitement in the sense that I'm able to connect with you, which I don't know if we normally would have connected with you or your group if it were not for the pandemic. I've also attended way more conferences than I have without making the carbon footprint this year, and have had really exciting, rejuvenating conversations with a lot of scholars that I wouldn't normally be able to engage with. So I think taking the opportunity during the pandemic to be able to forge connections with others. And I think this may not be related to what you were asking, but I think one thing that I always tell graduate students or undergraduate students, like people that I mentor, is to be not afraid to ask for things. I think just as you reached out to me, like the worst thing that can happen is that they don't respond or they say no. But I think as I was a graduate student, or especially as an undergraduate, I felt very timid in reaching out to researchers. But I always want to encourage that a lot of times the answer might surprise you and it might be a yes. Yeah.
No, thank you very much, Elisa, for that. And if you allow us, we would like to continue in contact with you. If the students have some question later, maybe
Of
I can
course.
send it to you, and you can reply us as soon as you can. And thank you very much, Elisa. We are going to send you a certificate of your participation today that is going to be signed by the vice-rector, the Dr. Ignacio Martinez Laguna, that is the chair of the Office of Research in the university. So we are
Oh,
going to send you your certification, and we are going to continue talking to you by email, because one day when the things are going better with this pandemic, we would like to invite you to come here to Puebla in Mexico
oh
to
wow.
our
I would love that.
university and have here a talk with our students. And I would like to start also soon collaboration, because it's amazing your work. As I told you, it match a lot with the things that we are doing. So thank you very much for your talk today, and thank you very much for this. I hope you have a good time with us.
Thank you so much. I look forward to being a collaborator and to continue to forge connections with you as well as other students. And feel free to email me at any time if any of the students want to talk further about any of these ideas.
Perfect. Just wait me a moment. It's a couple of minutes only to close the transmission, and also to invite all the people that are watching us for the next talk. Is Monday. Is very soon. On Monday we have Michelle Donsala. She has a master degree in psychology. Also, she works with hierarchical Bayesian models of creativity. So it's going to be a very interesting talk on Monday 11. So I'm going to share the link with you. And now we are going to close the transmission. Thank you very much to the Vicerrectoría de Investigación y Estudios de Posgrado and Rogelio and Yadira for taking this session with us. And we don't say goodbye, Elisa, just wait a couple of minutes. So just we close the transmission and we continue in the session. Thank you very much to everybody and have a good day. Bye.